Good morning, girls. In the last class, actually, we were discussing, completed the first normal form completely. I mean, finished it, but as I have muted the last 7 to 8 minutes of the video because I had some disturbance at my place, so it was very much noisy. So I muted and I forgot to unmute when I started recording again. So that's the reason there wasn't audio for that particular time. So I'm repeating it again today. So actually we have this, I have told you about how to convert a table into a normal table into a normal form. So that it satisfies all the conditions which are applied to a normal form. So what are the three um, steps that you have to, or three actions you have to perform to convert a relation into a normal form? Or here basically the first normal form is to eliminate the repeating groups. So already we have discussed what are repeating groups, so you have to eliminate the repeating groups. And next, identify the primary key. Yes, you have to find out a suitable primary key for that particular relation, because there are a number of keys for any particular table, like candidate key or super keys. There are a number of candidate keys for a table. So from those candidate keys, you will be selecting a primary key. So you have to identify a suitable primary key. And next, identify all dependencies. So already we have discussed what a dependency is. Dependency is nothing but getting identified with the help of other attribute. So here getting identified with the help of the key, that is normal. That is fully functionally dependent, right? So the attribute is getting identified by the key. That key can be a single attribute or a composite in the sense more than one attribute, 2 to 3 attributes. Generally we will use single or 2 attributes, right? So if the non-prime attribute, the attribute which is not part of the primary key, will be identified with the help of a primary key, then it is okay, it is fully functionally dependent. But where comes the problem. The problem comes when there is partial dependency and transitive dependency. So what is partial dependency? A dependency based only on a part of a composite primary key is called partial dependency. Already I have told you, here the key is made up of two attributes, project number and EMP number. But this project name can be identified only with the help of project number. There's no need of EMP number. So this attribute is being identified with the help of only a part. The EMP number both together make the primary key, but project name is identified only with this, can be identified only with this, with the help of this uh, uh, attribute, project number. So this is called partial dependency. So the opposite of fully functional dependency is partial dependency. And the other type of dependency is transitive dependency. So what is transitive dependency? A transitive dependency is a dependency of one non-prime attribute on another non-prime attribute. So an attribute which will be determined by another non-prime attributes. Both are non-prime attributes. No attribute in these two attributes which is getting identified, which is getting determined, and which is the determinant. Both are not part of the primary key. See here, job class and charge per hour. So if you want to find out what the charge per hour is, so you have to use job class, and you have to find you can find out what charge per hour is with the help of the job class. Yes, so neither job class nor charge per hour are part of the primary key. So what is the primary key here? Project number and EMP number. So there exists a transitive dependency here. So when you eliminate these partial dependencies and transitive dependencies, that will give rise to second normal forms and third normal forms. So this is what I have told you in the uh, last class. So here we are representing normal forms in a simple format. In single line, we can define the normal forms like this. First normal form, it should be in a table format, no repeating groups, and primary key should be identified. Okay, primary key should be identified, and also the dependencies should also be identified. Next, second normal form, the table should be in first normal form and no partial dependencies. If in the first normal form you will be identifying the dependencies, right? Different kinds of dependencies. It can be fully functional dependent, partial, and transitive. Fully functional dependent, no problem at all. That is what we need in a table. When there are partial dependencies, you have to eliminate them. If you eliminate those partial dependencies, then automatically the table will be in second normal form. Third normal form, second normal form plus transitive dependencies. So automatically the table should be in first normal form. It should not have any partial dependencies as well as no transitive dependencies also. Yes. And next one is Boyce Codd normal form, BCNF. So every determinant is a candidate key. This is called special case of third normal form. So what is determinant? So the determinant left part of the functional dependency or dependency diagram is called determinant, right? The key or the attribute which is determining the other attributes, right? So every determinant is a candidate key. This condition has to be satisfied if your relation has to be in Boyce Codd normal form. So fourth normal form is out of our range, so I'm not going to discuss about it. I mean, it is not in our syllabus. It is out of our syllabus. No need to discuss about it. So we have eliminated the repeating groups here. So we have filled the empty rows here with values. So we have eliminated the repeating groups, though there is some redundancy. We will overcome this by splitting the table. See, this is called the dependency diagram. The most important part that you have to write in your answer. If you miss this, then it will not fetch you any mark. You will not get even a single mark for the answer for normal forms, right? So the most important part of your answer should be the dependency diagram. So see here, this diagram is called dependency diagram because it is showing how other attributes are depending on the key or non-key attributes to get determined, right? So we will classify all these dependencies into three categories: fully functionally dependent, partial dependency, and transitive dependency. So the attributes which are underlined are will constitute your uh, primary key. Yes, and with the help of this primary key, you will be able to identify all other attributes, rest of the attributes in the table. Next, partial dependencies. What are partial dependencies? Project name can be solely, I mean, it can be identified only with the help of project number. So no need of employee number to identify what the project name is. So there exists a partial dependency. We are treating this two combination of these two as a key, but project name is dependent only on a part of this key, right? Only a part of this key. So that is giving rise to partial dependency. Here also you see employee name, job class, and charge per hour. To determine these, you need only employee number attribute, so no need of project number attribute here. So that is the reason it is resulting in a partial dependency. So next you are also identifying a transitive dependency here. So charge per hour and job class both are not related to the key primary key. You are just, but still there exists a dependency. I mean, to find out the charge per hour, you should take the help of job class. Okay, so if you want to know what a particular designation, like job class is nothing but the designation is charging, how the person is charged, so you have to know the job designation to find out the charge per hour. So this is about your first normal form. So let's move on to second normal form. So what is second normal form? So see here. So to convert a table into second normal form, the first criteria is the relation should be in second normal form, first normal form as well. So for a table to be in second normal form, first it should be in first normal form. First normal form conditions ఏంటమ్మా? Repeating groups eliminate చేయాలి, primary key ఏంటో తెలుసుకోవాలి, and as well as find out the dependencies, right? Now we are what second normal form is. See, converting to 2NF is done only when first normal form has a composite primary key. See, if your primary key is having only one single attribute, I mean only one single attribute is treated as a primary key, then there is no what you say partial dependency at all. ఎందుకంటే ఒకటే attribute ఉంటుంది, all other attributes are dependent on that attribute, part of the attribute కాదు కదా. ఎప్పుడైతే టూ అట్రిబ్యూట్స్ ఉన్నాయో ఆ టూ అట్రిబ్యూట్స్ లో ఏదైనా ఒక దాని మీదే డిపెండ్ అవుతుందో దట్ ఈస్ రిజల్టింగ్ ఇన్ పార్షియల్ డిపెండెన్సీ. కానీ ఇక్కడ when your primary key itself is having only single attribute, then no partial dependency, so automatically your what you say table is in second normal form. So అలా లేనప్పుడు then only we will try to convert that table into second normal form. See, if the first normal form has a single attribute primary key, then the table is automatically in 2NF, I mean second normal form. So let's see how to convert a table if it has what you say composite primary key into a second normal form. See, write each key component on a separate line. So actually your composite key is made of two attributes, right? So you have to write the two attributes separately on two different lines. So our primary key is made up of what? Project number and EMP number. So I'm writing those two attributes on two different lines. Project number on one line, EMP number on one line, and next original composite key on the last line. So this original composite key, I mean a combination of these two, which we are treating as a primary key actually on the last line. So you have divided into three separate parts. One is only project number, one is only EMP number, and one is both combination project number and EMP number. Now what happens, you see, each component will become the key in a new table. So each component, each attribute that you have written separately on separate lines will be treated as a key for a new table. In other words, see, the original table is now divided into three tables: project, employee, and assignment. So just by writing the attributes separately on separate lines will solve our problem. I mean, it will give us the idea to divide the table into n number of tables depending on the requirement. So we have three lines here, so automatically it gives rise to three tables. One is project, one is employee, and the other one is assignment. Next, now we have divided, right? Now second step is assign corresponding dependent attributes. That means the attributes which are depending on these attributes to get identified or to get determined. అంటే ఇప్పుడు వచ్చే వాల్యూ, ఫర్ ఎగ్జాంపుల్ ఇప్పుడు ప్రాజెక్ట్ ఉందమ్మా, ప్రాజెక్ట్ నేమ్ తెలుసుకోవాలంటే మీరు కంపల్సరీ ప్రాజెక్ట్ నంబర్ తెలిసి ఉండాలి. సో ప్రాజెక్ట్ నేమ్ ఇస్ డిపెండెంట్ ఆన్ ప్రాజెక్ట్ నెంబర్. సో అలా for each and every attribute you should write the corresponding dependent attributes. So for project name is a dependent attribute. For employee number, EMP name, job class, and charge per hour are the dependent attributes. Next, for assignment table, assign hours. Number of hours assigned to that particular person will be the dependent attribute for this key, which is a combination of project number and EMP number, right? Okay, so the number of excuse me, yeah, because the number of hours spent on each project by each employee is dependent on both project number and EMP number, because that employee is working in a project, so you have to know the project number as well as the employee number to calculate the number of hours he has worked, like so that is the reason we are writing this assigned hours into a new table called assignment, right? So see, this is the dependency diagram for second normal form. Okay, so this is conversion of first normal form into second normal form. So this project name is dependent on project number. Next, EMP number will determine EMP name, job class, charge per hour. Okay, and in the final assignment table, these two attributes combinedly help us to identify the assign hours values, right? So this is how you convert a table into second normal form. So but still you have a transitive dependency existing here. When you remove this transitive dependency, automatically your table will be moving from second normal form to third normal form, second normal form to third normal form. So first in this step we are just converting our table from first normal form to second normal form, right? So this is how you will convert a table from F1F first normal form into second. How each key component should be written on separate lines, and in the last line we will write the total key, I mean a combination of those two attributes. So after writing this, you will create tables based on these key components, which will where these attributes will be the primary keys. And once you find out the tables, you will find primary keys for that tables, you will be assigning dependent attributes, and attributes which are dependent on these keys, you will put them into those tables. So you will get a clear idea how to split the table into three different small tables. A big large table is now being split into three small tables. So you will come to know how you have to put these attributes of the big table into త్రీ డిఫరెంట్ టేబుల్స్. అది మనం ఎలా కంక్లూడ్ చేసుకుంటామంటే ఫస్ట్ ఆ టేబుల్స్కున్న కీస్ ఏంటో తెలుసుకుంటున్నాము. ఆ కీస్ తెలుసుకున్నాక ఆ కీ మీద డిపెండ్ అయ్యే డిపెండెంట్ యాట్రిబ్యూట్స్ని ఫైండ్ అవుట్ చేస్తున్నాము. సో ఆటోమేటిక్గా మనకు అప్పుడు ఆ టేబుల్లో ఏ కాలమ్స్ ఉండాలో తెలిసిపోతుంది. సో దిస్ ఇస్ హౌ యూ విల్ క్రియేట్ split the tables and create three new tables: project, employee and assignment. Madam, what is the use of splitting these tables? Yes, there is a use, because when you try to delete an employee, then it will not affect the project table. Why? Because a project law, if this employee, only one employee is there in that project, if you are trying to delete that employee, the project details could delete it. In the same manner, vice versa, there is only, if in a project only one employee is working, you are deleting that project, this employee details will also be lost if it was a combined table. So ippudu ala kaakunda, when you are maintaining different tables for them, what happens? Only the deletion happens for employee, only the deletion happens for project name. So you will not lose any data, or there will be no deletion anomalies. In the same manner, insertion ki kuda meeku problems tagutai. Insertion anomalies, deletion anomalies, updation anomalies, all will be reduced or eliminated when you go on converting the relation from first normal form to second, and second to third, third to BCNF. Okay, so this is about your second normal form. In the next class, I will explain about third normal form. So this diagram is also very much important for the answer, right? Next, a table whose primary key consists of only a single attribute is also automatically in second normal form once it is in first normal form. So this is what you have to keep in mind. So once a table is converted to first normal form and for that table only one single attribute is being used as primary key, then automatically that table is in second normal form also, right? ఎప్పుడైతే టూ అట్రిబ్యూట్స్ తోటి కాంపోజిట్ కీని మనం యూజ్ చేస్తామో అది పార్షియల్ డిపెండెన్సీకి దారిస్తుందో when it will cause partial dependency, then you have to apply these two steps and convert the relation from first normal form to second normal form. Okay. So have a nice day, girls. Take care. Thank you. If you have any doubts, ping me in the group.